All right, this is topic, actually, I don't know what topic it is. Topic 62. Okay, so this is topic 62, and this is a fundamental theorem of calculus, part 2. Now, in this one, we're actually talking about specifically about integrals that are being defined by a function. What I mean by that is that when you're trying to define, you're trying to find out what that is. All right, notice that instead of having between 0 and, say, 2, now you have a function instead of a constant. So to do that, let me show you kind of the hard way and then the easy way. Notice that after we take the integral of this, now we're going to take the derivative of that. Okay, so let's do it the way that we know how, which is you add 1 divided by 3, and we're going to find what the value is when you plug in sine x, and we'll find out what the value is when you plug in 0. So that's going to give me, see, sine x cubed over 3 minus 0 over 3. So this is just going to be sine cubed x over 3. Okay? So I'm just rewriting this. G of x is equal to 1/3 sine cubed of x. Now we're going to take the derivative of that. Now take the derivative of that. Remember that this would be a chain rule. All right, so that would have, let's see, that would give me 1/3 times 3. And I know this is sine squared. Remember that was a cubed here. Now it's going to be 3. Again, I'm taking the derivative times the derivative of sine, which is cosine. Okay, again, that was a chain rule. Alright, so that's going to be equal to, what is that? 3 is going to cancel, so we have sine square x cosine x. Right? So before I actually just show you what the fundamental theorem of calculus part 2 looks like, let me just kind of go through this, see if you understand this. Now if we're doing this, we're going to take this right here, we're going to integrate it and take the derivative of that. Okay, so if we integrate it, we know by the fundamental theorem of calculus 2 lessons ago that this is the same thing as this, right? And again, that was the fundamental theorem of calculus part 1. That's where that came from. Alright. Now, in this case, b, the upper limit happens to be another function. So we have f of g of x. So we have a function within a function minus f of a. Now remember that f of a, alright, so that's where we're at right now. Now what we're going to try to do after that is we're going to try to take the derivative of h of x. So we're going to take the derivative of h of x. Right, when we do, we have to do the chain rule here. So we have the derivative of the outside times the derivative of the inside minus the derivative of f of a. Remember that f of a is, that's when you plug in a number into that function and you get a numeric value back. To be precise, you get a constant back. So the derivative of a constant is 0. Again, this would be a constant. Okay, so that's where you get a 0. Now, let me rewrite this here. So therefore, h prime of x is equal to f prime of g of x times g prime of x. Okay. Now, it turns out that this right here, however, this is what f of t were or is. Okay, so again, the derivative of this, notice that if I take the derivative, this would be technically h prime of x right here. Okay, so now that's f of t. Okay, so that's going to give us that h prime of x is equal to f of g of x times g prime of x. Okay, so if you're looking at this and you're wondering, okay, do I have to do this? I would hope you understand it, but if you don't, here's what this is actually saying, and that's actually going to save us a lot of time, okay? This is going to be a shortcut. Shortcut to problems like the one above. Like the one above, to be precise, where integral is defined by a function. Okay, so let's do it knowing this. Okay, so if g of x is equal to this, and again, I'm just rewriting that equation that I had at the very beginning of t squared dt, the derivative, I notice that normally we have to take the integral and all that like we did at the top, but now all we have to do is, what that means right here, is that I'm going to plug in this sign right here. So I have sine of x squared times the derivative of g of x. Now the derivative of sine is cosine. So this is equal to sine square x times cosine, which is what we had at the very top. Okay. So again, let's do a few more problems here, and now I'm going to show you what the fundamental theorem of calculus says, part 2. All right, that's what we have there. The important thing again is this right here. All right, you're assuming that f and g are continuous. All right, so when you see the capital F, that just means the integral of f of t. All right. So in this one, we don't want to know the integral necessarily. We want to know the derivative when you plug in those values. Now notice that I can do the fundamental theorem of calculus part 2 because my upper limit is a function. All right. So all we're gonna do is we're gonna plug in. Let's see, f prime of x is gonna be equal to. Let me see. Again, let me write that for you because that's kind of important. We're going to use the fundamental theorem of calculus, part 2, when the top bound is a function. And the bottom bound is a constant. Okay, so again, I can use the fundamental theorem of calculus part 2 because the bottom is a constant, the lower bound is a constant, the upper bound is a function. So all I have to do now is I have to plug in x squared instead of t, so I have 1 minus x squared times the derivative, not of all this, but the derivative of just this function. The derivative of x squared is just 2x. Now notice that this would have taken a lot more work if we would have done it the way that you knew. If we would have integrated and, well, first of all, yeah, if we would have integrated, it would have taken a lot longer. Okay, so, and really at this point you don't even know how to do that. Okay, so we have 1 minus x squared. All right, let's go to the next one. Same thing again. I can use the fundamental theorem of calculus part 2 because the bottom bound is a constant and the top bound or the upper bound is a function. Notice that's an x cubed. I know that's kind of hard to read there. All right, so same idea. We have the derivative, and again, remember that we're looking for the derivative. We're finding f prime, capital F prime. So this is going to be equal to sine of x cubed square times the derivative of x cubed. Derivative of x cubed is 3x squared. Okay, So now the answer is going to be, well, really all I have to do is just rearrange this and I'm basically done. 3x squared sine of 3 times 2 is 6, so x to the 6th power. That is that. Alright. Now on the next one, alright, if you look at it, my bottom bound is a function. So therefore, I can't use the fundamental theorem of calculus part 2 because the lower bound is a function. Or it's not a constant. Okay, so it's not a constant, so therefore I cannot use the fundamental theorem of calculus part 2. So on this one I do have to integrate this. So that's going to give me t squared x plus 1, which is equal to x plus 1 squared minus x squared. And that would be x squared plus 2x plus 1 minus x squared. I'm just simplifying at that point. So f of x is equal to 2x plus 1. So f prime of x is equal to 2. Right, so again, the lesson here is that you cannot use the fundamental theorem of calculus part 2 because the lower bound is not a constant. Okay, so let's go to the back here now. I found the next few examples kind of fun. Alright, so notice that it says right here that the graph of a differentiable function f on the closed interval between 0 and 7 is shown below. Alright, so this is this function f. Alright, again, this is function f. So now they want us to find h of 2, h prime of 2, and h double prime, or the second derivative of h. Okay, so let's do the easy one. We know that h of 2 is the integral of this, correct? So all we have to do is h of 2 is equal to f of t dt. And this one, since we don't actually have the function, we have to do it geometrically, so we're going to find the bound between here and here, between 1 and 2. So we're going to try to find the area of those two triangles. So this is 1/2, 1 times 4. Again, I'm getting that triangle from here. This is the base of 1, the height of 4, plus 1/2, 1 times 3. Okay, again, this is the height of 3. So if you do the simple math here, you get that this is 7/2. Okay, now the next two, you have to do a little bit of thinking. Now, if h of x is the antiderivative of f of t, that implies that this right here is h prime of x. Okay, so let me write that down. So h of x is the area under the curve, we know that. Area under the curve. We know that in this case h prime of x is equal to f of x. Remember, I'm talking about f of t. F of t is the derivative of h, right? Because if we integrate h prime of x, well, we get h of x back. Alright, so we know that. So that also implies, therefore, that the second derivative of h is the first derivative of f. Okay? So basically, if we were taking a derivative or we're looking for slopes, the slope of all these lines at each point would be the second derivative of h. Alright, so with the information that we have, let's see, we have h prime of 2. Now remember, h prime of 2 is the same thing as f of 2, so that's actually really easy because all we're looking for is the y-coordinate at x is equal to 2. Let's see, if x is equal to 2, y is equal to 3. So that's that for that one. Okay, so that's that answer. Now, the second derivative at 2, that basically means what is the slope at this point. Now, because this is a sharp point, alright, this is kind of a sharp point there, we're going to say that the derivative or the slope at this point does not exist. Alright, because you have a peak, a sharp point, if you will. Alright, let's take a look at the rest of these. Now it says, write the equation of a tangent line to h of x at x is equal to 2. Alright, so we want to write an equation of the tangent line of h of x at 2. So what do we need to write the equation of a line? We need a point and we need a slope. So we need a point, and that point is 2 comma h of 2, right? The y-coordinate of h. We don't, and we know what that is actually because that's what we found right here. Alright, so we know that this right here is 2 comma 7 over 2, so there's our point. And now we need a slope. We need the slope at 2. Now, luckily, we already have that here also. So that's equal to 3. Alright, so finally, the equation of the line is y minus 7 halves is equal to the slope times x minus 2. Let's see, we got that right? Yes. Now to figure out the domain of h, well, the domain of h is going to be the same as what we have here. Alright, so make sure that it's between 0 and, let's see, 1, 2, 3, 4, 5, 6, 7. It's between 0 and 7. Okay? So the domain is between 7 or between 0 and 7. So that one's not a big deal. Alright, again, I hope this doesn't seem too difficult. I should be back Monday unless something terribly happened to me or I lost my flight. So if you got any questions, try to do your best tomorrow, which is Friday hopefully. So try to do your best until I get back on Monday. Okay? Again, if you got questions though, send them out.